Hello, Math 2. This video is part 1 of 4 videos on factoring. Okay, factoring is extremely important for the next few chapters and in future math courses. So the first video here is talking about factoring out the greatest common factor. Okay, so first off, what you have to know is anytime you multiply two numbers together, right? You are multiplying factors together. Okay? So these are factors. And when you multiply the factors together, you get your product. Okay? So when we talk about the greatest common factor, right? We can take and list factors for any number or term. So let's take a look here. Find the greatest common factor for the following terms by using their prime factors. So if I look at the factors of 12, meaning what numbers multiply to give us 12, I know I can do 1, I know 2, 3, 4, 6, and 12. These are the factors of 12 because I can multiply 1 and 12, 3 and 4, 2 and 6, all to get a product of 12. Factors of 18. So I know 1 and 18 would work. I know 2 and 9 would work. I know 3 and 6 would work. Okay, so these are the factors of 18. So what is the greatest common factor? What factor is in both lists? The greatest number that's in both lists is 6. So we would say that 6 is the greatest common factor. Now, it doesn't get much different when we add variables in it, but if I list the factors of 20, I know 1 goes into 20, I know 2, I know 4, I know 5, 10, and 20. Now, for the variables, when I look at x to the third, the factors of x to the third are x to the third, x to the second, and x to the first. And the factors of y is just y. So when I look at 28, the factors of 28x squared y, I know I have 1, 2, 4, 7, 14, and 28. Factors of x squared would be x squared and x, and the factors of y would be y. Now when I look at the numbers, what number is the greatest common factor? Well, if I look here, 4 is the largest number in both lists. Now for the variable expressions, I know they both have x squared in common is the largest, and then both of them have y in common. So my greatest common factor would be 4x squared y. So let's take a look at number 3. Find the greatest common factor of the following terms. Well, when I look at 12 and 27, what I like to do here is list the factors of 12, right? Such as 1, 2, 3, 4, 6, and 12. Then what I do is I work backwards and cross off the ones that don't go into 27. So I work from the biggest to the smallest. 12 doesn't go into 27. 6 doesn't go into 27. 4 doesn't go into 27. Which one does? 3. So I know 3 is the greatest common factor between 12 and 27. Now I have to look x squared and x. How many do they have in common? They have 1x in common. So 3x would be the greatest common factor. Okay, the next one, 10 and 20. You should know right away that the largest number that goes into both 10 and 20 would be 10. But when I look at a to the fourth and a to the third, how many a's do they have in common? They have 3 a's in common. So a to the third would be the variable expression. The last one here, number 5. If I look 4, 8, and 10, if I write the factors of 4, you have 1, 2, and 4. That's it. Well, I know 4 goes into 8, but 4 doesn't go into 10, so that one can't work. 2 goes into 4, 2 goes into 8, 2 goes into 10. So 2 is part of the greatest common factor. I have x squared, x, no x. Since 10 does not have x part of it, right, I cannot say any variable is part of the greatest common factor, and 2 is the GCF. So what does this all mean for us, right? Well, if I take this expression here and I distribute the 5, okay? So 5 times 3x squared is 15x squared. 5 times negative 10x is minus 50x. 5 times 2 is 10. So if I had this expression, now we want to take this answer, right? And we want to work backwards and undo what was done in number 8. So basically, anytime we are factoring, we are undoing, undoing the multiplication, right? So when I look at 15x squared minus 50x plus 10, how would I work backwards and factor this out? Or get back to where I started. Well, if I look at the greatest common factor between 15, 50, and 10, I know that 5 is the greatest common factor. But if 5 is the greatest common factor, how do I get this expression here? I think the easiest way is once you find your GCF, all you're going to do is go ahead and divide everything by the GCF. So 15 divided by 5 is 3. I bring over the x squared because nothing simplifies there. Minus 50x divided by 5 would be 10x. And 10 divided by 5 is 2. So anytime we're factoring out the GCF, the first thing we're going to do, step 1, you're going to find the GCF. And the second part is divide everything by the GCF and write as a product. Okay, so let's take a look here. If I look at number 8, what would the GCF be here? Well, if I look at the factors of 10, right? Factors of 10 are 1, 2, 5, and 10. What's the largest number out of this list of factors that go into 15? 10 doesn't, but 5 does. So 5 is part of my GCF. Both terms do not have an x, so 5 is my GCF. So I pull the 5 out, and all I'm going to do is divide each of these terms by 5 to figure out what goes in the parentheses. 10x divided by 5 is 2x. 15 divided by 5 is 3, so plus 3. And this is how we factor out the GCF. How can I check my answer? Well, what's 5 times 2x? 10x. 5 times 3 plus 15. The next example. When I look at 4, 8, and 14, I'm going to take the smallest coefficient, 4, and the factors of 4 are 1, 2, and 4. 4 goes into 8, but 4 doesn't go into 14, so I can't use that. 2 goes into all of them, so my GCF here is going to be 2. Not every term has an x, so I cannot pull out an x. So I know it's going to be 2 times. How do I get my leftover polynomial? Divide everything by 2. 4x squared divided by 2. 4 divided by 2 is 2x squared. 8x divided by 2 is positive 4x. 14 divided by 2 is plus 7. And I have just factored out the GCF. Next one. Well, 2, 10, and 12. The largest number that goes into each of those is 2. So my GCF is 2. And if I look, though, I have x to the third, x squared, and x. Each term has an x. How many do they have in common? Well, I'm basically going to take the smallest exponent, which is x. So my GCF is 2x. Now I pull it out, and I'm going to divide everything by my GCF. So 2 divided by 2 is 1. If I have x to the third divided by x, how many can cancel? If I have 3 x's up top, 1 on bottom, they cancel. What do I have left? X squared. 10 divided by 2 is positive 5. If I have 2 x's on top, 1 on bottom, 1 cancels out, I have 1 left. So plus 5x. Here, 12 divided by 2 is 6. Both x's cancel out, so that's what I'm left with. And this is factoring out the greatest common factor. Okay, so what you're going to do now is you're going to go and use this concept on the student practice. Let us know if you have questions.